will be presenting our speaker, Dan Capello, Nasuni.
Happy to kind of walk through just my experience, and I hate to say it, my experience over the last 15 years or so with cloud technologies, and kind of where we are today. And everything is market driven, what we're doing and what we've done. So it might give you a different perspective on the cloud, how companies start to adopt the cloud for certain use cases and things like that. But a show of hands, who deals with the enterprise storage in your environments today?
One client is using it.
Okay, and it's typically, is it cloud-based? Is it mixed? Okay.
It's cloud. Most of what I do is local.
Okay, yeah, and that's really, in the grand scheme of things, that's largely what the world's made up of. I mean, the world's made up of a traditional system that is typically, to use Mark's term, break fix, and it's about I buy a device, I spend a capital budget. Is it okay if I sit here?
Oh, yeah.
There's a mic there, maybe we should aim it at, but ask Steve.
That's fine.
We're good? Thank you. So, and that's the way I would say $30 billion a year gets spent, right, on companies like EMC, on Windows file servers, on NetApp devices. And so we have a very unique perspective on how we go about helping large enterprises kind of adopt the cloud, and in particular adopt the cloud for file services workloads. So to put all of this in context, I was going to go through some slides. Maybe we'll jump into them as we go, but let's just make this a discussion, and happy to kind of answer questions about kind of things that we've experienced over the last few years. But the company, the first company that Mark mentioned was a company based in Waltham called Archivus. We set out to build an object storage sort of layer, right? So we're a software company. And who's familiar with object storage today?
Not very.
It's built on this idea that you don't want to have one monolithic controller, you don't want to have one monolithic storage environment. You want to kind of be able to cobble together a bunch of commodity pieces of hardware, like for just raw storage and for compute. And you need a layer above it, right? You need a software layer to tie all those things together. And that in object storage is really like a big distributed database, right, in a lot of ways. And it's a matter of, an object is a piece of data with its metadata. And that metadata tells you what you should be doing to that data, and the software that's running above it is keeping everything in policy. So a piece of metadata might be, for this type of file, scatter 3 versions of it throughout the entire cluster of random nodes, so that you could have a single node fail anywhere and you never lose your data, right? So this has great and wonderful data protection qualities to it, meaning we're not susceptible to a single point of failure anywhere in the system. So a piece of networking can go down, hard drives can fail, and we're still serving up files as need be. The way you talk to object storage is a little different than the way the enterprise works today. That's usually through what is a RESTful API, cloud language, puts, gets, things like that. And it's great. Like if you have the wherewithal to change your application or change the way your users are addressing the storage to write across a RESTful API, that's awesome. Then you have access to this wonderful sort of commodity-driven storage subsystem that can grow infinitely and expand infinitely. Like you are just adding commodity hardware everywhere you go. The object storage backend is the basis of what S3 is. It's the basis of what Azure is. Azure Blob Storage is in the cloud. In Archivus in 2003, we made one of these layers for object storage. And then we started working with big enterprise storage vendors to try to get it to market. So we OEM'd our software to Hitachi Data Systems, and they created a big storage product called the Hitachi Content Platform. We started to work with people like IBM. This is a long, long time ago. And HCS decided, you know what, this is a really strategic storage sort of play for us, and we're going to buy the whole company. So they bought the company in 2007 for about $125 million. Now, the reason I share that number with you is because the sales, didn't really marry itself to the price tag. Meaning, I would say we had a handful of customers, you probably count them on both hands. They were very big customers, and a lot of them were federal agencies. So there was people like the NSA bought into this, NASA bought into this. And at the time, in 2004, 2005, they were dealing with petabyte problems. Like, petabyte problems now are pretty common. Like, it's pretty easy to find customers that are dealing with storage problems in the petabytes.
Is that one out for terabytes?
That is, it's 1,000 terabytes. So, some of the world's biggest manufacturers might have an exabyte of data, which is 1,000 petabytes. We know of one customer that has that much data today. But there's a lot of sources for this data creation, and this is, in 2004, 2005, mainly those were government agencies that were doing, large.
IRS.
They were doing things that required that level of scale, and so they needed something they could just buy a bunch of commodity stuff in and build it and not worry about little things breaking. So that was great, and object storage is great. And but one thing I think we learned at Archivist was it just really doesn't fit natively in the enterprise. The enterprise speaks CIFS and NFS natively. Applications speak CIFS and NFS. And what we felt we really needed to do to address the true market opportunity, which is a $30 billion a year spend against network attached storage devices, was create a file system and design it to be married to an object storage backend, not to sort of a LUN-based block backend. And so that's what Nasuni did, and we've been doing it for 8 years. So we went through the first phase of this process, I would say, if this is like a big journey here, or is to understand really what object storage can do, and now the second phase with Nasuni is to really unlock that for the enterprise. One of the things that also was a barrier to entry is that it's like a blessing in disguise for object storage, which is it's one of the, I would say, few systems, at least in the storage world, that it really, really is better with scale. And it gets stronger with scale. It doesn't become problematic with scale, because it's all designed to just add more compute, add more storage, and continue to let the software kind of do what it needs to do to protect your data. So that can be a tough proposition for a regular enterprise to adopt, right? Like if I want to take on this challenge of buying racks and racks of commodity hardware and stitch it together, and it may be an easier play on some level, but at the end of the day, it's still work that I have to do. About the time that Nasuni we were becoming part of Hitachi, Amazon was coming out with some of their web services in S3. And we knew that Microsoft was also coming out. So I say this all the time, having been part of an organization that was trying to convince the world that object storage has a place in this world, and then figuring out what the economics of that really meant, and not, in the grand scheme of things, not having like huge commercial success, to seeing Amazon and Microsoft invest billions of dollars in the most durable storage and networking infrastructure probably in the world, and then saying to rooms like this, saying, hey, take what you need, pay as you go. I mean, it's a great gift. Like, so I'm a big fan of public clouds, right? But there are barriers to adoption, right? There are security concerns, there are performance concerns. And those are things that at Nasuni, we felt we had to get out in front of very early on to make, cloud storage, real cloud storage, be adopted by the enterprise. And so that's what Nasuni does. Nasuni is a file system. It gets delivered as an appliance. It can be a virtual appliance. It can be a piece of hardware. Our goal is never to mark up a bunch of commodity hardware and sell it to a customer at an enormous profit. Like, we try to make that we just try not to lose money on hardware if we sell hardware. So we just market it above our cost structure. But what we found in this journey is if we can solve performance and we can solve connectivity, like giving a native SIFS and NFS interface, and we can solve security, then cloud storage really can be a reality inside the enterprise. So, we've been around for 8 years. We're based in Natick. We're about to move into the Seaport. We've got over 300 enterprise clients. We're managing today over 23 petabytes of customer data. So we add about 150 terabytes a week, or at least our customers do, to the system. And in doing so, we've never lost a piece of data. We've never had a data corruption event. And so that speaks to, I would say, two things. I would say it's the IP of the file system that's been created. It's good. But to the backends we support as well, right? So really Azure and AWS, we do testing on a bunch of different public clouds out there. They are enormous. They are very much enterprise class and very strong components to what we deliver to our customers.
Question about solving connectivity. Is it somewhat related to the software-defined network? Implementing software-defined network?
It's more about giving a cache on site, right, behind the firewall, and being smart about that cache. So a lot of our customers will have hundreds of terabytes of data, but they'll have a 20 terabyte device behind their firewall. And that 20 terabyte device has algorithms that will look at most frequently accessed data, keep a local copy, so that there is no difference in performance to what they were traditionally deploying, whether it was a NetApp or a VNX or anything like that.
Not like prefetch?
And it can prefetch. So if we have a cache miss, right, we can recognize certain data types and start to stream it in. Like, for example, if you had a video file that you wanted to bring in and start using, we'll recognize it as a video file and you'll start to have access to it before the whole thing is down.
And if you're single-sided, what do you do for your own duplicate center?
Yeah, great question. So the system is designed, and I'd say there's a recognition in creating the system that there are complexities to delivering usable capacity, right? It's not just the type of storage you choose. There's a backup environment, there's a replication environment, things like that. All of that's built into the system. So the system operates as a series of snapshots to the cloud, just like a NetApp might to another NetApp, except we're putting it into a unique cloud account for that customer. So the data protection is all built in. So we set a snapshot schedule, typically 15 minutes. The data is compressed.
But again, on a physical basis, you're still single-sided.
Yeah.
So what happens if something happens to your site?
Sure. So if there's a piece of hardware, it's got traditional RAID protection and things like that built into what we deliver. But more importantly, there's a transition that happens in our system versus a traditional system. When you snap your data to the cloud, the transformation that happens is now the authoritative copy or the gold copy of your data is now held in the cloud. Once it gets written there, multiple copies are being made in the cloud account. There's 3 copies or 6 copies, depending on what we choose on the back end. So your system, your data is not tied to a specific device. It's not tied to a specific location. So a site can go down, right? And we make it very easy to either have a warm standby in sync with that cloud account, or to just resynchronize that
Well,
data.
maybe
with the
what
cloud
I'm
account.
missing, are you saying that, I thought I understood you to say it was your environment that was providing that cloud, or are you just the in-between, you're broadcasting it to other clouds outside of your location?
Oh yeah, sorry.
I didn't get that part.
Great, yeah. So great
So
clarification here.
you're using Azure and Amazon Web Services, and you're making it safer to use in that.
We make a very familiar control. It's a hybrid system essentially, but we make a very familiar. Yeah. So we didn't want to go out, start a company, and try to build a better data center than Amazon, right? In particular because it's a great system that they have. So typically a customer's going to choose which cloud they want to use. Either we'll support Amazon, we'll support S3, and we'll support a whole host of private clouds. So if a customer is large enough and they chose to buy their own cloud, like the product we made at Hitachi, that's one we support. EMC has a pretty well-known one called ECS, and then IBM just spent $1 billion on another sort of upstart private cloud company last year. So we work with all those guys behind the scenes. But that's the goal, and that's the market push that we see. So what we see people going to the cloud, we see most people saying, I've done my email, right? Email's on the cloud, I don't have my own Exchange server anymore. I've done my CRM, right? I use Salesforce, I use a bunch of, maybe the Microsoft product. How do I bring cloud economics into my data center now? How do I go out and get, all I hear is that prices are dropping in the cloud and that's the least expensive stuff out there. How do I bring that in? And what we recognized, I think, a while ago was that doesn't just come in natively. Like that you have to have a familiar front end to that to provide security, to provide a local copy for performance, and most importantly, to provide native SIFs and NFS access.
Most important, last thing you said?
Protocol access, SIFs and NFS, right? So the expectation is you don't have to go out and rewrite an application across REST to address cloud storage. You certainly don't have to do something different for your users. They can still go to the same mount point, map drive, things like that.
Again, the reason, when I was at Broadleaf, the reason why we like this product so much is because we had a number of clients. It's great if you have one site, but a lot of our clients have multiple locations, and they were not necessarily all, New York and Boston. Some of them was, New York and Shanghai, and Hong Kong, and all over the place. And again, by having the authoritative copy, not local in Boston, but in the cloud, which is accessible to everyone, then everyone had access. Once it's in the cloud, it can get populated all over. Then you could have very good access all over. Am I still in front of this?
No, you're doing great. No, I'm not.
and what Nasuni also did was to have some intelligent file locking, so that not only could I be working on my document here in the Boston area, but someone in Hong Kong could also be working on that document, and they have the intelligence to say, hey, you can't overwrite what the person in Boston is doing because he has it open right now. So again, as your company scales and as you have more sites and more diverse sites or whatever, the product looks better and better.
Yeah, there's certainly distributed organizations gravitate towards us because of that, the ability to basically create a global file system, right? So now we put a file system and made it resident in the cloud, and then any location where you have a filer, again, it can be just a free virtual filer connecting in, can be synchronizing read-write access all around the world. So I'm in Boston, I save a file, it's immediately available halfway around the world, and we can be working away. And the best part is that users have no idea that they're doing something different, right? There's no change in, where they're going to save their data, how they're accessing it. We're not putting them into some weird portal or anything. They're going to the same sort of map drive and saying, oh, I'm going to the G drive, because that's where I know all the projects are, and I'm going to save it and work out of that.
I may be off base with this question, but I've got some customers that have been interested in the cloud, and the reason they couldn't go there is because they have some embedded legacy applications that do exactly that. They handle their own file data, their own file locking. They can't move to a SQL or a data manager. Are you saying this type of system would support that so that up in the cloud, the same type of locking system that they see locally would be extended that way?
Yes. So we've written the global file locking to just emulate a single site, right? There are certain applications in the world that have weird semantics around file locking, right? So you might have a big engineering file that when you open it up, you're actually opening up a bunch of subfiles as well, right?
Okay.
So we have a lot of experience in certain verticals where we see a lot of this kind of crazy file locking stuff, and we've optimized for a lot of those applications. But generally speaking, it's designed to work out of the box with any application that has a file lock.
So I'm really impressed by your data record. It's amazing. For 8 years, basically, I think it's pretty perfect.
Yeah.
I'm curious about, I think the big worry a lot of us have expressed in this group is kind of a mixed group on the cloud thing.
Sure.
And I think that some of the concerns people have expressed is concern about, I guess you call it agricultural homogenization. It's like if all the feedlots are all the same, and they all have the same kind of cows, if there's a disease, it's going to run through all the feedlots. And one of the advantages to having a lot of diversity is it makes it less likely that's going to happen. And basically, this system is taking a lot of what used to be independent organizations and linking them to what's 2 or 3 very, 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 very large systems. And we know from hard experience that very, very large systems sometimes can fail catastrophically. And I just saw an article about net neutrality, and I was curious about just how the whole cloud thing, how safe that feels to you over the next 10 years, whether it's going to be subject to threats, international threats, technical threats, virus threats.
Yeah. So I would say our experience is if I just look at the underlying subsystems, right? So in the SLAs that these organizations push back to any of their customers, right? It's like a 5.9 data availability is generally speaking kind of what they're offering back. Like if I'm storing my data in S3, I can expect 5.9's availability and resiliency from them. And then there's different levels of Azure that are similar rates and things like that. They are less prone to being hacked and things like that, just because they're so distributed and they're pushing the data all around a lot of different data centers. But that being said, you can be disconnected from the back end, right? So our model is one where it's there's 2 things, I guess, that happen in our model that would probably be relevant here. One is it's hybrid. So we do expect the active portion of the data to be living behind your firewall, just like it was before Nasuni showed up. And the algorithms that run on the devices will take care of that natively. You can certainly pin folders and make sure that you have a local copy of that data. So if you lose connectivity to the cloud, you still have access to your most relevant data to you, right? And typically that has not happened very frequently. You know, there's a pretty publicized AWS S3 outage about a month and a half ago. That's the first outage we experienced with those guys in 8 years, right? And we're doing constant testing against that system. We'd had one against Microsoft as well prior to that, because they failed to renew like an SSL certificate. It was pretty, it was an embarrassing failure. And they were out for 12 hours. And we were I think the second company in the world to file a ticket with Microsoft, because kind of the other interesting thing that we're doing here is every filer in the world reports back to our NOC. So we get to see like, hey, we can't see Azure anymore, and that's where all of our data is ultimately living. You know, we had filers all around the world raising their hands saying there's something wrong. Not one of our customers in that outage lost access to their data, because the caches were sufficient enough. The outage was 12 hours, been gone for 36 hours, maybe we would have had a cache miss, but at the end of the day, like, there was a hybrid approach that I think allowed us to ride through some of these blips. And there will be blips, right? Absolutely. Like, I don't think anyone thinks it's impermeable, but there are a number of things that are set up architecturally that allow us to kind of ride through these things.
Would it make sense for any company, given the cheapness of storage, to simply on a regular basis copy everything down to our drive?
So this is the thing. This is what I think what we recognize as a company, and what we thought the business model really was here, wasn't about just the storage. It was about a couple other components to it. There's a storage element to it. There's a data protection element to it, and then there's a sort of a data resiliency element to it, like and business continuity element to it. So those are the primary things that the appliances allow you to solve for immediately, right? I've got my storage, it backs itself up to the cloud, and oh, by the way, if Boston goes away, within minutes, I can resynchronize the entire file system. And that could be a 25 terabyte file system, it could be a 25 petabyte file system. We can resynchronize immediately because the data is living in the cloud.
How can that happen so fast? How can the resynchronization happen so quickly?
Because the file system itself is living in the object storage platform. And so when we snap a data set for the first time, the transition happens, where now the authoritative copy's in the cloud. This filer here is just a window into it. So, and it's pretty granular. So it could be roughly every 15 minutes. It could be shorter than that if you want. We recommend every 15 minutes. So you are getting your data up to date every 15 minutes. And that's your recovery point in any failure scenario. So if a site fails, we make it very easy, if you hadn't planned ahead, to have a warm standby, to download a free virtual filer, put your credentials back into it, and it'll resynchronize with that cloud account. And you'll be right back to where you were.
So what you have downstairs is basically pointers to the data in general, with some files cached, but mostly pointers.
Exactly.
And that's what you're synchronizing, is the pointers.
Exactly.
That's why it's so fast.
Exactly. So like really is it works inside out. Like it starts at on-prem because that's where your data is, but ultimately the file system is resident in the cloud.
So do some of your customers opt to cache everything?
No.
Can you repeat the question? 'Cause
Oh
might not
yeah,
be
sure.
something-
So the question is, do some customers opt to cache everything? The answer is no. We make it attractive, I can tell you, not on purpose, but like, you know, our devices are inexpensive. But most evolve to, I'm thin provisioning this much larger data set in the cloud.
When you say cache, does cache refer to a local storage or a cloud storage?
The local storage.
Local storage.
Exactly. So cache in our world is the local storage that's got the most frequently accessed data. serving up local copies to a particular site.
Is there any similarities with Akamai type of system?
So are there any similarities to Akamai? So that is a great question, and it's almost like we fed it to you, but I know we didn't feed it to you. Maybe Glenn did. What's that?
His check is in
Yeah, right. You'll be the winner of the mug. So the company history is so our founder. So I've worked with Andres since the late '90s. I know it's difficult to believe that I was actually working in the late '90s, but it's true. I was. So Andres, we had built a software company in Cambridge, and we sold it to the New York Times. And Andres became the CTO of the New York Times. And in 1999, the New York Times had problems with keeping up with big news stories, ironically, right? Every time a big news story would come up, sometimes the sites would crash because they couldn't handle it. So, and he would tell you he made the brilliant decision to hire Akamai as a relatively young startup. And that changed everything, the way he viewed it. You know, a bunch of smart MIT people at Akamai saying, hey, we can keep these things up and running for you. You don't have to worry about that. You worry about writing the news, and we'll worry about keeping your web servers up all around the globe. And so that's a model that was very important to us, I would say, because what we're doing at Nasuni is we're trying to do for enterprise storage what Akamai did for content delivery. So absolutely, because we deliver it as a service for our customers. And one of our founding engineers at Archivist and at Nasuni was one of the early engineers at Akamai. So like got a lot of that DNA in our bloodlines. But, no, I don't think I am going to show it, but I could run through some stuff, I guess, because we've talked about a lot of it, and my clicker broke. So, so what do we see? And this is just a general kind of slide deck that we share around the world. What do we see in enterprise storage today? We see a lot of hyperconverged for block, and we see a lot of fast disk, right? And that's an old world model. What we see in our world is that those subsystems don't really address unstructured data, and unstructured data is painful. And so that's what Nasuni does with cloud as the back end. And the reason we look at unstructured data is because it's really complicated, right? It's far less complicated, and it grows very, very fast. I would tell you, we talk to our customers about data growing 30% a year. The growth we see more often is more like 50 to 60% a year. And it could be maybe we're just getting the biggest problems coming at us, but we see a lot of explosive growth.
Dan, could you give us an example of a company that has this kind of data growth and what kind of data it is?
Yeah, so we are a generic storage subsystem, right? So we didn't go out and design ourselves to go into one particular vertical, but there are certain verticals that gravitate towards us. Architecture, engineering, construction firms, they come to us all day long. They have large files. Unstructured files are the lifeblood of the company, and they've got project teams scattered around the world. They got to move data from point A to point B.
When you're using this word unstructured files, could you say a bit about that? What do you mean by that?
Unstructured. So what's the difference? Unstructured data versus structured data. So in structured data, we would be talking about databases, stuff that you could take a really sort of consistent look at that data set, and it typically requires like a block-based sort of fast disk I/O performance behind it. Unstructured data are CIFS, NFS workloads. They are home directories. They are flat files. They are everything that your users call you about because they can't find anymore. Right?
Image and the video? image, is that part of
Video,
it?
photos.
Absolutely, and so to answer your question, Adam, as far as types of companies that gravitate towards us, media companies. 4K video might be the greatest thing to happen to Nasuni in 4 years, but they just have unbelievable growth of files, and again, distributed organizations.
File system, do you include Linux file system like CFS? Would be structured or unstructured file system?
It's unstructured.
And how does it differ from like HPFS or distributed file system, the HP?
So one thing about our file system, so how are we different from like an HPFS or GPFS, sort of clustered file systems? So we're not clustered file system, but we're at the end, we're also not bound by things that, we don't have limits on the size of our file system, right? So we're not bound by inode counts, we're not bound by number of file counts, and we're not bound by size of files, like a traditional file system might be. Which again, when we start looking at very large data sets, a lot of these other file systems will break down that way. So in our world, that's largely because everything's built behind an object storage subsystem, which gives us sort of unlimited access to a repository.
How do you handle big videos or large image files?
So how do we handle videos or large image files? Just like any other file. So before any data goes to the cloud, and we send that data up to the cloud, it's compressed, deduped, may or may not affect a video file very well, but it's also chunked. So a lot of the cloud providers will have limits to the size of file that you can have, and that can be a barrier to entry. We're chunking those up, partly for security reasons, mainly for networking reasons to move that data easier and quicker, and so they just look like any other file for us.
When you go to download things from, say, like YouTube or Apple Choice or other places, depending on which download tool you're using, you generally need more than one because some new change or something's going to mess up any one of them at any one time or any two or three. There's a huge selection of file sizes, and not only MP4s, but WebMs and everything else. Are they storing it at one really high resolution and then dynamically changing it on the fly as it feeds to you, or are they actually storing all those different formats, or a little both?
So the question is,
I know some of the download tools will promise to change it to anything you want, but for the most part, are these other people doing that, or is it really stored the same video in a whole lot of different resolutions?
the question is, how are video files being stored, and are they multiple files at different resolutions? To be honest, I don't know. I don't know the answer to that.
If you go to archive.org, you may find several, but you're not going to find dozens.
Yeah, I mean, in a system like Nasuni's, we'll store whatever comes in, right? And so if you wanted to store multiple files, right, or have multiple options in your namespace, right, you'd have to put them there, and we'd save whatever you get. So we have a term, garbage in, garbage out. Anything other than that?
I have a follow-up question. Do you have any large customers like a TV station or a large graphic publishing company?
Yeah, we do. We have, I have a slide here that will show you that here, I think. So there's some people on here that you would recognize, like this is just a subset of some of our customers. I think it's on there. TBWA is part of Omnicom, so they're one of the largest media companies in the world. They've got about 8 petabytes of data on us, so they're a significant customer of ours.
But in a sense, when you say they have 8 petabytes of data on you, what's really happening is the data is actually at Amazon or Microsoft. And you're essentially the broker, in a sense.
Correct. So we're delivering this as a service, right? So we're delivering their file services as an ongoing service. So we write an annual contract based on usable capacity. And with that annual contract, you get all the features that we ever create. You also get all the support that we have, and the service itself that we're providing is cloud-based. So we're based in Natick. We have a support team that sits in Natick. We have a support team that sits in London, and our NOC is cloud-based. So we build out a lot of the features and functionality of what the appliances can do, are reporting back to our NOC, and they're performing these activities.
So the appliance comes with the yearly price, essentially. You throw in the hardware, we pay a yearly fee, and you just take care of it. You bring in the hardware, whatever you need.
The hardware is the one thing that's a la carte. The hardware is the one thing, but that being said, we always prefer virtual appliances to be leveraged. So because those are free, those are part of our licensing. So if you need hardware, you buy it, you own it. It's a typical CapEx expense. It's very small in relation to the other dollars that you're spending with Nasuni. But you have a very active support environment that's provided through the NOC. Also, the advanced features like save this file in Boston, make it available in Shanghai and Tokyo and San Francisco at the same time. That's all coordinated through our NOC as well.
But does everyone have hardware in their office, or do some people opt not to have any hardware?
You have an appliance.
Yeah.
That appliance could be a piece of hardware. That appliance could also be a virtual appliance. So that's how we deliver our file system to you is across that appliance. Yes?
Yeah, do you get involved in the on-premises, the local caching or the local firewalls? Stuff like that?
Yeah, so the question is, do we get involved with local firewalls and local caching?
Yeah, this designing of the local system, in other words.
Yeah, so absolutely. So we'll go into an environment. We'll talk to the customer about the use case. We'll want to really understand for a particular site what are the IOPS requirements, right? So like, how many users are there? What kind of applications are going to be hitting up against this? How much data would we estimate needs to be local? And then we'll sit down with them and say, okay, if you were going to resource a free virtual filer, this is the resources you'd want to bring to the table. If you don't have them, look at one of these 2 or 3 appliances from Nasuni. We can sell you the hardware. And then it does sit behind your firewall. It's an important aspect of this, is because it's still under control of that IT organization. Right? It still looks and breathes just like a network attached storage appliance, because that's exactly what it is. It's just now this thing is back-ended by a cloud.
And how is the security of the files guaranteed when it's under Amazon or Microsoft?
Great question. So how is security guaranteed in the solution? So before any data ever leaves a filer, it's encrypted. It travels encrypted in flight, and then it sits in that cloud account under AES 256 encryption levels. Those encryption keys are created and maintained and owned by the customer, not by Nasuni, not by Microsoft or Amazon or anybody else. So the appliance is providing that local performance for us behind the firewall. It's also the point of encryption and decryption in the whole system as well.
So every single file that's sent by the system on the cloud is encrypted?
Yeah, it's ones and zeros in Amazon.
But to go full circle, for the data to be usable, it has to go through your NOC, because you're the one who's taking that raw stuff that's on various websites and turning it into an object, a database object.
In order for any cloud, any clouds, any data that you've stored in Nasuni that's now resident in the cloud,
Right.
has to be read through a Nasuni filer, because it's going to decrypt the data.
Now, is that filer the local device, your NOC, or both?
Oh, so the NOC, oh, so I'm sorry, our NOC, so yeah, so the NOC sits outside the data path, right? So it's really when you send from your filer a piece of data, a snapshot, it goes directly to a cloud account that you've linked
Okay.
to that
It's not
device.
going through your NOC?
No,
Okay.
but the NOC is then also communicating with the filer to provide, make this part of the data set available in this location. Open up a global file lock for these folders here. You know what I mean?
If your NOC is unavailable for any reason, does that file path still exist from the customer straight to the cloud?
Yes. And what would happen so the question is, if our NOC becomes unavailable, what happens to
The data flow?
the data flow? The data flow is intact. The more advanced features would be suspended, like global file locking, multi-site movement, and things like that.
It's like the phone company or an ISP. They can see the traffic flow, they can see the metadata, but they don't know what the contents of a given piece of data is.
Yes, and we don't know what the metadata is either, so that's encrypted as well. So the metadata and the data are part of that encryption that go to and from the cloud.
Okay.
We get different communication around making data multi-site access or globally file locked.
Yeah. What's the, I'm sorry, go ahead.
You haven't talked about the virtualized environment. Is that included? What's the virtualized environment in relation to the file system, or does it matter? Or?
So how does virtualization play a role here? So so our appliances can be run as virtual appliances. We support ESX, we support Hyper-V, we support that being run on-prem on resources that a client would provide. We also support that in Azure and EC2 as well. So you can run a free virtual appliance in those locations. We don't charge you anything for virtual appliances. Every customer we have uses them in production, so they're not an afterthought by any stretch. They're very robust part of what we do, and the goal is to give you as much access as you can to the service. So we want to make virtual appliances free, so you never think twice about, hey, should I bring that site on or not, or should I use this use case? Just spin up a virtual appliance, give it a shot. If it works the way you want it to, great. If not, give us a call, we'll help you work it out.
You don't need a NAS device locally as long as you have a virtualized image.
Exactly.
VM.
Exactly. We replace NAS storage ultimately, right? So if you had say like a tin tree system, and you wanted to carve out a little bit, a small part of that to give to a Nasuni cache, you can run a virtual appliance on top of that, and then you never have to buy another NAS for as long as you live. Adam.
What is the lowest end that can access your service? A lot of us work with smaller customers, and just curious about, is this kind of service available to us?
The lowest end is works out to be about $50,000 a year. So we are looking at like mid-enterprise and above.
Are you thinking of having resellers break that up?
We have worked with, we have done one sort of, I would say, experiment with a managed service provider that's in its early stages, so that you could buy a smaller footprint and things like that. But really, there's a lot of support that goes into bringing on, anybody. We had to draw the line somewhere. It's roughly around $50,000.
That virtual appliance at each customer site, I assume, could get overloaded, or so you need redundancy, but you also may need more of them just to carry the load. how
Sure.
many gigabits a second or what are you measured in, is each one be able to carry, and beyond that, you have to have others that operate in parallel, and then you have some load balancing way.
So the question is, how do you scale basically a site if a particular site gets overloaded? So two things there. So if you're running just a virtual appliance, it's easy to often just add more resources, right? So you can do that, and then you can leverage things like for redundancy, like vMotion failover between VMs, right? So if you wanted to go all virtual, we have a ton of customers that will do that. If you're really just a hardware customer of ours and you exceed sort of the IOPS requirement, you outgrow it, typically you have to split the workload. Like, we're not a clustered system today. It is like a longer range roadmap for us, but today you would split the users or split the workload or combination of the two, and you'd have two separate devices.
So in some sense, it's like two branch offices, but they happen to be all the same.
Exactly. That doesn't happen as often for us.
So how many, say, gigabits a second? It really depend on which hardware you're using.
Yeah, so I would say it's funny. Some of our low-end hardware devices, we think of this more in IOPS, just like can keep up
I was
with
thinking in gigabits a second. Like, you're going to have to get some. You're not going to hook into the local cable company, most likely. You're going to get some special dedicated circuit.
Oh, to the cloud? Like how?
From the local office out.
Oh,
So how much bandwidth do they need, or is it? I'm sure it varies fairly widely, but a lot of the higher end services you just don't call up Comcast or Verizon and say deliver it tomorrow.
Yeah. So we like to see just IP to the cloud, and like a base use case, we like to see 20 megabits shared. There's QoS on the devices, so you can say, this time of day you can have this much bandwidth, this time of day you can have more because no one's here.
20 megabits.
Shared to the cloud.
Those companies are big enough, they're gonna have a Class A connection.
Much more of that to their house.
Yeah, and then if you're going into a like if you're really doing some globally sharing data, like with active global file locking, I like to see closer to 50 megabytes shared.
Does your company have an opinion about net neutrality?
I don't think we do. And I don't. Yeah. So I know, and that's just because for no other reason than I don't think we've ever really talked about it.
You don't think it will have any effect one way or another?
I don't know.
Can you talk a little bit about disaster recovery?
Sure.
How do you implement that?
So DR is really just one of those pillars of functionality that's built into the system. So when a new client signs on with us, we'll work with them to understand where the sites are, what's the flow of data today, and then most importantly, what's the failover between sites? If Boston goes down, how do you want to handle failover? And so the data, it's in our world for DR, it's not so much about rebuilding a site, it's about resynchronizing with the core, right? Because the data is now held in the core. So that can be a DNS failover, a DFS sort of group switch that can happen pretty quickly. The worst case scenario, if you didn't have a plan, you can download a free virtual filer and resynchronize in under 15 minutes and serve data. So there's a number of ways. It really just depends on what tools the customer feels comfortable using.
So is it in addition to how Amazon Web Services handle the disaster recovery by replication to different zones? And then you come in and you cache, you decide how you're going to cache to which site. There's a
I got what you're saying. So in our system, when you're creating a volume in the cloud provider, you're making some decisions about how you want the back-end data to be stored and how many copies you want to be stored. So in Amazon, you really only have a chance to get 3 copies. In Azure, you have a chance to get 6 copies, although I'd say it's a little excessive, to be honest with you. You pay for it, and that's great, but you can choose at that point which zones your files are living in. It's a little. You're really just going to a set of credentials. So we're just looking at a set of credentials and doing a put or a get against the cloud credential that you've inputted. So we don't really. It doesn't really matter to us where the zones are on the back end. It's just a web address.
I don't know if you can answer this question, but I often wonder about it. Before we had this, and we had this complex, old-fashioned data stuff, and then we have this new cloud-based stuff with your stuff in front of it, has the actual cost to a customer on a yearly basis changed dramatically?
So that's a great question. Let me go back. The answer is yes, but I would say for not every environment, right? So when we look at the market opportunity is because this slide changes and you see a bunch of different names on it, right? So storing a piece of data isn't about just paying EMC, it's about paying EMC and Commvault and having a location at SunGuard for DR. Like there's a considerable stack that goes into real protection of data. If your requirements are less than that, you know it'll be a different conversation about value, right? So yes, I would say if you're buying tier 1 storage and you're backing it up and you're using vendors like Commvault, Avamar, things like that, the economics are pretty straightforward to go to the cloud because we drive all the cost out of that model, and we offer it in conjunction with cloud providers. It's not a big CapEx expense anymore, right? So it's not a speculative spend anymore. You've got 100 terabytes, we'll license you for 105. When you need the 106, call us and we'll get it to you. It's not, hey, I got 100 terabytes, I got to build this thing to last me for the next 3 to 5 years. I think I might need more like 450 terabytes, and if I build it, it will come. And that may be the case, but you've tied up your capital, right? The other element here, which is great, and again, I say this all the time, I'm not a AWS or Microsoft salesperson, but those two companies are racing to the bottom. And like they can't wait to get a lower price out the door, right? And enterprises benefit from that. So last month, for the storage that we use on the back end, which is Azure blob storage, which if you're on Azure with us, they dropped the price by 26%, right? Like, so just one morning, every IT group in America and around the world woke up and said they just took 26% off my cost structure, right, for that product. So
how are they doing
that? Scale. I mean, I think that they view a lot of times some of the cloud products as loss leaders to get other workloads into the cloud. So storage is a pretty straightforward dumb disk behind the scenes, and they just keep battling it out and drop the prices. So I think they do some of it with scale. I think they do some of it with larger business plans to get compute workloads into the cloud and things like that.
I guess I'm puzzled about how this is going to be sustainable. Every bit uses some energy, right, to store. Somewhere there's a disk, right?
Right.
Somewhere?
Yeah.
And that disk is spinning somewhere and it's using energy. And so I'm wondering how this is gonna work over the medium and long haul is one thing I'm wondering about.
Yeah, and I don't know the pure economics other than what spits out at us, right? Which is, they keep lowering their prices. But I would think some of this, at least in this part of the world of cloud, which is, the basic object storage on the back end, there may be a longer useful life for the basic components, right? Without a penalty, right? Meaning, maybe in a traditional model, you would have a SAN that would be available to you for 4 years or maybe 5 years if you stretched it. Because if that goes down, you have a RAID group, and then after that you're figuring out how to recover your data, right? Whereas in a cloud, in an object storage, it's all commodity to begin with. It's completely redundant, and the software is continually staying in policy. So maybe I've got a group of commodity servers that have been on the front line for 7 years, right? So I've just eked out more useful life of that capital expense without the penalty of failure, because if it fails, no big deal, no one notices it, we just replace it with something new.
I guess one of the concerns that some of us have is just about, these servers now are someplace else, right? They're India, they're like in places far away. Is that where they are?
Well, so when
Amazon stuff?
when you're creating, they have data centers all around the world, and certainly for data sovereignty, it's important to understand for certain companies where their data is being held. So when you create a volume, you create a storage account in that cloud provider, you're also choosing this is going to be in Northern Virginia, and it's only ever going to replicate to Oregon, right?
And you pay more for those choices, like for different regions?
Maybe every now and again a little bit more, but it's basically very similar pricing.
So there's not like some much.
When that storage gets large enough, right, that's got to be throwing off some major heat. I mean, there has to be a local energy issue, grid issue, things like that.
I'm wondering about India or third world countries hosting these servers.
Yeah, I mean, I don't know. I mean, obviously, yeah. I mean, they are.
I know this sounds far-fetched, but look,
How do you sleep in?
it's not easy. What I'm wondering about, here's the thing. One of the things we've learned from Edward Snowden is that things we don't see often are things we may not like very much if we did see. And so one of the things I am noticing about this process, it's too good to be true. It's wonderful what you're describing. Basically, we're suddenly getting this huge, inexpensive hard disk somewhere that we pay rental for. We don't even have to pay a capital expense for. It's fabulous. The data's retention rate is fantastic. It's completely secure. It's like a miracle. And I just can't help but wonder, because we can't see it, and we can't see where the disks are or how they're being used, that it's like not knowing how the hot dogs are made. And so I'm just wondering if that's something we ought to be, I'm just proposing that for all of us, that we might want to be thinking about this and being aware of it.
Yeah, and to be honest with you, I would think that there's probably documentation or communication from the providers on. I mean, they certainly do a lot of documentation on like how secure they are, why they're secure, things like that. But how eco-friendly they are as well. I mean, I would think that there's a. I've never looked for it, but I would think that there's a big story to be told there. Thank you. I think